So we are solving round 876. An array is given consisting of zeros and ones. It is good for all integers I from 1 to n. Both of the following are satisfied. I by k of the first I elements A are equal to 1. Yeah. I elements are equal to 1. Now, array of good is for all I from 1 to n. Both of the following are different. I by k of the first I elements of A are equal to 1. K last I elements of A are equal to 1. Possible number of ones in a good array. Okay. So this is like this is at least. So we want at least one. Then we can put some zeros. Then we need one. Okay. So distance of k 0, 0, 1, 0, 0, 1. In this now when we come here, I by k will be equal to 2. So so my thought is the answer will be n minus 1 by k CL of n minus 1 by k plus 1. So to do that, because we just want 1, 0, 0, 1, 0 here, and then for extra one, we will put one here, and if there are more zeros, then we have to put extra one here. So this does it, I guess. Let's see. 2, 3, 4, 7, 4, 3, 2. Seems to pass on sample. Okay, let's go and let's open all the other problems. For now, let's not open the last problem. It might be a. You have n lamps number from 1 to n. Each lamp I has two integers ci and ti. At each moment, the lamp is in one of the cases. Can be turned on, turned off, or broken. Usually, all lamps are turned off. In one operation, you can select one lamp that is turned on, turn it on. You can't turn on the broken lamps. You receive DI points for turning I on. Following happens after each performed operation. The number of lamps that are turned off is X. Do not count. All lamp sizes is AI less than or equal to X simultaneously break. Turned on or off. The broken lamps never count as turned on, and that are turned break, you still keep points received for turning it on. E number of operations. Okay, so we have turn on broken lamps, which is VI points lamp I. There's no number of lamps that are turned on X. Broken lamps do not count. All lamps I such as A less than equal to simultaneously break. They are turned on or off. Okay, so if I have Initially, I have zero lamps turned on, and all the lamps break. I have like 13 is to 15 points. The answer. Okay. So, like I am drinking tea right now. So, we can do that. AI, comma BI pairs. So, I will maintain a set of numbers that I can potentially take. Not guaranteed, but I will potentially take these numbers. Okay, so I will say uh, b.cpp. Okay, let's go with this. So I will use maybe set. Set I think seems usable enough. Multi-set. We will have to use multi-set because of the nature of the problem. But okay, we are only given an. No, you can argue. We will have to use multi-set. So we can say that if n OS size is less than I, then insert V. And if OS dot begin, and we will continue here. OS dot begin is less than V. Begin, insert V. Evaluate OS dot begin, not OS dot end. Zero. Does accumulate work on this? Okay, it works on multi-set as well. 13, 9, 10, 0. Okay. D was I, comma, B of I, comma, OS. This seems pretty interesting. 9, 12, and 1. Oh, this was supposed to be V. That has 13, exactly 2 less. 12 and 13. 1. Okay. This seems to be the problem. Okay. We have 3, 4, 5 here. Okay. 5. How is it 14? In second test case, we can take both operation turn off receive 3 points. Turn on lamp 4 and receive 3 points. And in second operation, you turn on lamp 3 and receive 5 points. Turn on. Turn on lamp 5 and receive 4 points. 2, 3, 5. Okay. So our lamp break. I did not take lamp breaking into the consideration while coding. Broken lamps are not counted as the turned on lamps at that point in time. So each time when I take this lamp, I can take this lamp M and okay. So we didn't even need to do that. So we can just for all the points we can okay. We are still somehow wrong. Okay, for and j equals to 0, j less than I. We can so what happens is all the lamps that have I less than we have added some point, then all the lamps break below me if I have added enough. So at each point when I'm adding the ith lamp, I can add at most when I'm adding the lamps with AI is equals to I can add at most AI of these lamps because all the ages less than I will break. So this should be fine. Okay, this should not be fine. I am dumb as. I forgot to do the most important part. So I only need maximum, so I can just like reverse sort them and we will have maximum of I points in all of them. So my idea was initially that I was thinking that broken lamps were counted as the lamps that were switched on, but they are counted as switched off initially. So we don't need to care about them. Of course, pretest will pass because our solution was correct. And we move on to C. C has very less solutions currently. I would rather just you are given sequence A1, A2, An of length n. Each element is of whether which is either 0 or 1, and the sequence B, which is initially empty. You are going to perform n operations on each of them. You will increase the length of B by 1. Either on the ith operation, you choose integer P between 0 and I minus 1. You insert 0 in the sequence B and P plus 1 after the first P elements, and then you invert the first P elements of B. You know the sequence B. BML on the ith out, you choose an integer P between 0 and I minus 1. Replace B with equal. Here, expert denotes the binary inversion. Okay, you can first determine if there is a sequence of evolution that makes B equal to such a sequence. Between position P plus 1. Okay, so this is fun. So what I care about is this. So after all the operations, initially I should have 0. Okay, so 0, 0. I think all the sequences are possible. Okay, this is not possible. 0, 1, 1. Here I put 0 and all the others are inverted before me. Okay, so the last should be 0. Because if the last was not 0, then all the others were not inverted before me. So the last should be 0. And I will choose the first 0 right now that I have. 1, 1, 0. Something like that will happen. And I will choose now this will become 0, 0. Okay. So something like this will happen. 1, 0. So I will choose this 0. Then this will become 0, 0, 0, 0, 1. Okay. So I think I have a valid arrangement of this position. Okay. Seems pretty easy to, I think, visualize that last should be 0 because we cannot insert 1 at last position in any way because last position will be inserted at last. Okay, so we are not ever inserting 1. So if we insert 0, then my main idea is there will be something like this. So I will first take this first 0, then these ones will become 0 and these zeros will become 1. And I will take the first one here, then the first 0, then the first one, and I will keep going on and print this, and I will count the extra remaining ones. And at these many times, I will print 0. So I think this should be enough to give me the correct solution or not, or maybe because okay, so this 0, all the zeros after me. So this will be 1. Then this was supposed to be 0. Then I will print all of these are 0. Okay. So we have a pretty interesting construction here. We are going to do this 0, then insert this 0 and this 0 after that. So these three elements will be inserted in this order. This 0 will be inserted at its position. This 0 will be inserted at its position. and this zero will be inserted at its position, or these zeros will be inserted first. Okay, these zeros will be inserted first, then this will be inserted at this position, and then these zeros will be inserted first. So initially, if I have something like 0 0 1 1 0 0, then I have some. Initially, I will insert things like 0 0 and 0, this and this. Then I will have inserted this 0 here. Then I will have inserted this one, this 0, which was here initially, and this will be 0, and this will become 1 1 0 0 0. Then I will insert it with this 0 here. So I have made it 0 1 0 0. So then, okay, and B, that's 0 for int I is equals to 1 plus 1 I plus plus is P of I. A of I is not equal to A of I minus 1. Then B dot push back I. Okay, if S dot the out, not that question. Then otherwise, the out, yes, and the out, the out is 0. Okay, then I think this should be enough. A dot back should be 135 is 0 2. Okay, so I first insert all the positions at 0 and 12. Well, I think this is more likely than not correct. We will know once we submit. So the idea was pretty simple that we just, yes. So the idea was pretty simple. How we wanted to put things in order. Okay, D. Well, that's a big problem. There are n colorful balls arranged in a row. The balls are painted in n distinct colors denoted by 1 to n. So this is the position. The ith ball from the left is painted in color Ci. You want to reorder the balls so that the ith ball from the left has color I. Scenario, you have created equal to 1 balls of color 0. You can use in the reordering process. Due to the strange properties of the balls, place ball of color 0 anywhere in the sequence. Need two consecutive balls before the leftmost ball or after the rightmost ball. Consecutive, keeping while the relative order of the other balls. You can perform this operation no more than k times because you have only k balls of color 0. Choose any ball of non-zero color such that at least one of the ball adjacent to him has color 0 and move that ball anywhere between the leftmost ball or the while in the relative order from this operation as many times as you want. But for each operation, you can pay 1 point. Okay, From these operations in any order. After the last operation, all balls color 0 magically disappear. Sequence of n balls of non-zero color. Hmm. So, minimum amount of coins you can spend on the operations of the second type. So that the ith ball of the second. After the disap what is the ball from the left is color I from all I from 1 to n. After the disappearance of all balls of color 0, it can be shown that the it is possible to reorder the balls. We want to solve the problem for k and oh, such a nice idea. So I want to move the balls to move this ball 1. I want to move this ball 3 here and 2 here. So this suffice. Moving this ball 5 is suffice. But so if I put one ball here and I put 5 here, okay, no. If I put one ball here, put 4 here, here, and 6 here, 3. So this not move balls front, back. This problem seems quite a bit hard. But yeah, after some certain number of balls, we don't really need them. Like after n by 2, the answer should be constant. So we actually need to look for just some small number of balls for like small than n by 2. Maybe even square root of n. Something like that might be possible. Oh, n is small. So for each ball, we have to solve it in for n square, for n cube for every ball. Some kind of dynamic programming. Yeah. Don't know. Don't understand the entire problem. Let's see. This is consider the given following part and initially an array even it is written on the blackboard. Can consider on each round the following happens. The player selects I such that a is greater than 0. If there is no such I, the first player loses the game. The second player wins the game. Player chooses J not equal to I, J happens. J, second player loses the game, the first player wins the game. Let D equals to F. J sentence is by D. If I is by D and the next round starts. It can be shown that the game always ends after the finite number of rounds. Which player play for first or second and win the game. Okay. I think some kind of maybe game theory, but we are so if he supposes chooses AI, I will choose another value v. So here first always wins because if you chooses 3, because all the numbers are different and after 3 rounds the game will end and first round. Okay, so in the first round one number becomes 0, second round one number becomes 0. There will be no rounds that both the numbers become 0. If there is no round that both the number becomes 0 in the end there is something XX remaining. Then first pair wins, otherwise the second pair wins. Here, how can I ensure that the second pair wins? The say first pair chooses 11. Second pair can choose 4. Then I get 5, 5, 7, 3, 2. This is 3. Then choose 5. Okay, if I can divide this into two sets of equal sums, then I win. Then the second pair wins. That's why this is quite small. Because if I can divide this into two sets of equal sum, then I can always choose, if this set, then I can always choose the opposite set, any element from the opposite set. Okay, so this works. This is quite interesting that this works pretty amazingly. But otherwise, the first pair wins. Now, I have a condition where second pair wins. But is it necessary that the first pair wins in the other cases? Because I was choosing D, can I choose randomly in that case? Can I just choose randomly that whatever I choose, you are not going to win anyways? Is that possible? That you are not going to win anyway because I am reducing some 2D at a time. Here, sum was odd, so this doesn't really matter. If sum was even, something like 2, 4, and 8 is happening. And I can say, okay, 2, 4, 8, and 6. 6. Okay, no. 10. Then, okay, 10, 2, and 4, and 8. Sadly, 12. I don't think anything should happen. Okay, 12 is good enough. So, 12. So, I say, okay, we choose 8 and 12. We are reducing by 2D. So, we will either reduce by 2. Well, D, and this is reduced by D. Okay, so let's try to prove. I am inside the set. Is reduced by 2D. Our difference was diff. And we are on the both side, and one of them is reduced by 2D. Then our difference becomes suppose 2D minus diff. One of them was D, and he could go there. Then that would not be the. And then our plus positive diff. Positive diff. And diff minus 2D becomes 0. Because it was diff, now Diff minus, it has become diff minus 2D. And now it's 0. Then it has 2D, diff was equal to 2D. Then sending diff here and D here would have been the same. Okay, so it is never possible in that case. Maybe. Or I don't know, there should not be a sequence in that case, sequence of operations. So I am basically trying to may do something. One. What? Okay, so I'm saying that okay, that right now equal to minus. This is query two. This is which minus h dot begin dot end. Okay, okay, something like that. Fine. Now we have both x and y. We have to chart. Then I print two. Okay, then I can just say two. Print four. Okay, then I can just say three. Then I print four. And just say four, five, six, 5, 3, 0, 0. This is correct somehow because I don't know about the first part. The second part of the query is definitely correct. If it is passed, interesting. So greedy did work. Somehow so many people have done D. I feel like E is a lot easier than sadly not many people have been able to do E, even though I took my sweet time implementing it. So my idea was that in E, the second part is pretty interesting that any player. So I proved it a little that we can choose any index, but that was a little vague proof. But I proved the part where like if there we can divide the sum in two. If he gives us one of the regions in the first part, then I can we can choose from the second part. If he gives the second part, we can choose the first part. So that's basically it for the problem. I think that's just complete problem. Well, I don't know whether I will be able to do D or not. D seems a little more bad. Like I don't understand what he wants us to find out. So I think maybe he wants us to accept that like dp of n comma a is we put first wall here. Okay. Then we will do some kind of iteration that okay, so I will use all the balls until this point to solve here. Okay, so I think this is possible. I actually think this is possible. So if I put my line here and I want these balls to put, so I can choose this one and I can put this one here, this one to sort. But how? Well, my doubt is that how do I? What are the transitions basically? That's my doubt. Like I kind of get that it's GP, some kind of DP that because first of all that the constraints like constraints are screaming that it's DP. Then the second thing is that I think it's something like DP of n comma k that we will pick some balls until here and sort them properly. That should be fine. I think it should be fine. That okay, so I'm saying that I will sort all the values until here. The problem is this 5 needs one swap to get to here. This 6 needs swap and this 5 needs swap. This 4 did not need swap before. It was at its correct position. I don't know. I legit don't know how to do this and I did this. Crazy. Well, crazy and funny. How to do this? So if I'm here, I said that I put the 0 ball here, then 3, 4, 1. Well, my concern is that, okay, okay. So my concern was that, like, if I'm putting a ball here, suppose somewhere like this, and the largest element in this side is equals to I, then I only need to sort some part of it. Like I don't need to sort all of it. If this is I and this is some kind of like this is I, then I will look back and say, okay, until here. So firstly, I put zeroth ball here. I can always say that. I can put first ball here as well, but doesn't really matter. Okay, so I would be at the correct location if all the balls before me sorted properly. If I moved all the balls before me, will I be sorted? So we will need to sort this 1 and 4, and as this 2 and 3 were already at their good positions, then they will be at the good positions. For this 6, this 5 is at its good position because like we only need to sort this 6. If we sort this 6 and like send it back here, then it will be the good position. But how do we calculate that? So this will be 1, 2, and 3. Pretty wild. Getting pretty wild, I guess. And dp of ij will be minimum of dp of I comma j minus 1 at least because why not? So let's say then first test cases are there. Okay. So I want to check for the effect effective ranges. Like the the part that I can bring some elements in front of me is something confusing. Because if I can bring some elements in front of me, counting the elements that are like some elements, I will keep them at their positions, at their original positions. Okay, so this ball, this is sorted, and this is sorted. This 6, I will send it to the 5 and something like that. So if this was 645, then it would be only take two operations. If this was sorted, this position. Okay, so if I say this one moves two gaps, these moves two gaps, and zeroth wall. But that would be bad if we think of something like zeroth wall. Feels dirty, but something like greedy or something that we put two walls somewhere that like this. Hmm. I legit don't know how to solve this problem. And this has so many submissions as well. I just want to look at my rank right now. Where I feel good because I solved this pretty fast. But yeah, D seems really hard to me. Somehow I don't have any idea how to do D. There will be some crazy trick. There will be some crazy shapes of DP around it. And cube. It's and cube also. Seems pretty unintuitive. So one is here. I put this here and like send this one in its position. Put this then here. Initially, four steps were required. I, I wish this was the case for every test case. Sorted. There's no need to worry about anything. We have to just sort the permutation. Hmm. If I put these two in their correct position, it would be sorted. After we can sort them. Is it one, two, three, and say, okay, something like this happens. Then I come the next one here and I say, okay, put this five here, there, and we can sort this too. Otherwise, use that thing and sort it in the proper order or something like that. Well, damn, this is hard to think about. Well, let's just do some random DB. Yes. Okay. Oh, can just do here. Six. That would be enough. I would not require more than n swaps, anyways. I can just say n plus one there as well. But yes. Oh, so all the swaps will be taken. What the answer is only five. You seems to be pretty interesting case here. Six, eight, nine, 10. Okay. These four elements don't need any swap. Use seven here. Then I can send seven here to 5, 11. Then I need four swaps here, one swap here. It is more like partition and choose some suffix here, some prefix here, some suffix. No. Okay. From each partition, choose some prefix and some suffix and put them in their correct places. Everything else will be sorted. Everything else is sorted. I want to pick this, pick in groups. So if I have one partition, I can pick one group. If I have two partitions, I can pick two groups. Three partitions, I can pick three groups. Now I want to pick the number of groups such that all the other elements are sorted. But how do I maintain that all the other elements are sorted? Okay. Currently, I am X. My maximum is MX. If X is greater than MX, then I can choose to not divide something here and pick MX. This is n cube dp, but with a better state. And so I have like maximum ij and max to maximum until now. Until now. Yeah, so we have hmm, okay. So we have J0, K0, and that 0, 0, 0. Okay. Command terminated, of course. Oh, okay. Shit, bro. Bro, this stand really with. Okay, so new DPS 00 was 0. I don't even know at this point why it is wrong. Why it is so wrong. Like this is not even wrong at this point. Lol. Uh, uh, if J plus 1 is the equal to N. Okay, we want to test only this right now. Like it is 9 cross 9, so should be checkable. New DP at 0, comma 0 should be 0. Don't know why it's 4, comma 1. Okay, okay, I get it. So this should be new DP of J, comma A by DP of J, comma K, comma 0, comma K, comma 1. K, K, comma 1. I will do this here, like J, comma K, comma 1 plus 1. I don't even know what the fuck is this? K, J, comma Here K is less than A of I. So new DPO J. So here, so here we will look. It should be 0, comma 4. Yeah, bro, why is it not 0? 'Well, initially everything should be 0 because why not? At least they got this right, bro. Only thing that's wrong is this one. 5 4 4 4 4 4 4. This should be 10 5 4 4 4 4 4 4 4. Well, the count of 4, let's see. Is it correct? Yes, the count of 4 is like the total number of output is correct. Hmm. Comma 11. 30, Anil, correct. I don't even know what is going on at this point. All should not be 0 there. Only few should be 0. Something like Sorry, let's see. So here I'm saying that this no, that is correct. That is correct. Should be zero. Okay, that should not be. That would here. Mhm. Yeah, I got it. Where I am going. It's a small case. One and two is increasing. Hmm. I don't know what is wrong here. Well, there are some random numbers here and there. Uh, Answer should be three. And BPF, one of four is only two. This is interesting. Yeah, this is 0, 1, 5, 1, 5, 1, 5, 1. Eight, 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 two, eight, 4, 4, 2, 8. If a max element is 0. 1, 4, 2. Hmm. This is interesting because I will choose every except. Hmm. Yeah, well, is 5 of 0. I can just do that. Just keep it. Okay. Let's see. Yes, well, 0 plus 1. dpfi of j. I don't know. Well, this DP seems pretty suspect. Oh, it passed. Ah, classic. Such a first DP passed, man. Well, the idea for the DP was pretty easy, I guess. The idea was simple that uh, the remaining array has to be sorted. So I will select some groups. Suppose I have selected G groups, then that will be the answer for G queries. And if I have selected less than G groups, I will take best from less than G groups and G groups. So I have selected G groups, all the other groups are sorted. The elements they have not selected are sorted, and I can select these groups and I can send them to the positions where they happen to meet. So this is the idea. I have basically solved the problem, but well, I could not write GP properly for this. This is pretty basic. Like this is the idea. We want to write DP such that we select G groups that we will select, and all the others should be sorted. Okay. So the state was basically J I comma J comma A of X, where X was the maximum element until now. J was the groups we have selected so far. 0 and 1 was parity, deciding that we are currently in a group that we have selected, or we are currently in a group that we have not selected. Okay, so this was the DP, I guess. Okay, I guess we will just roll out now.